In the last 72 hours, something subtle but unmistakable has changed in the light coming from 3I Atlas. When it passed closest to the Sun, instruments across multiple observatories detected a brief surge of radiation, then silence. The brightness curve dropped so sharply that for several hours the object nearly vanished from solar tracking arrays. Yet when it reappeared, it was no longer the same. Its albedo, the way it reflects light, had shifted. Spectral lines, once dominated by frozen volatiles, now carried traces of heavier elements: nickel, iron, and something else the sensors couldn't immediately classify. Researchers monitoring the event through NASA's stereo probes reported a faint corona of charged particles forming around it, as if the object had briefly fused with part of the Sun's own expelled plasma. Others dismissed it as a flare coincidence, but the timing matched too perfectly. The readings suggested that 3I Atlas didn't merely endure perihelion, it may have absorbed part of the solar environment itself. Across scientific channels, analysts are calling this the most mysterious phase since its discovery. If it did take in solar material, that means its internal structure or magnetic field behaved in a way no natural comet or rock ever has. And if it didn't, then the entire array of instruments around the Sun somehow misread the same event. Either possibility points to something unprecedented. Tonight we trace what happened near the Sun, how 3I Atlas emerged changed, and why some now believe it's carrying something inside it that wasn't there before. It began quietly, almost too quietly for something this significant. In the hours following 3I Atlas's closest pass behind the Sun, a set of narrowband readings from the Solar and Heliospheric Observatory showed a sudden sharp distortion in reflected light. For a few frames, the object's spectral line simply vanished. When it reappeared, its signal carried a deeper tone, fainter, denser, and strangely muted, as if something about its surface had fundamentally changed. Scientists monitoring the event compared it to an absorption pulse, a brief phase where the object may have taken in energy or material from the solar plasma itself. No one had predicted this. For months leading up to perihelion, every major observatory expected outgassing, fragmentation, or a loss of mass, not the opposite. Over the next several hours, data from the Parker Solar Probe and Stereo confirmed that 3I Atlas was no longer radiating the same way. Its albedo dropped by nearly half, while its infrared signature deepened, suggesting it retained more heat than before. The simplest explanation would be dust coating, but the geometry doesn't fit. The readings imply an increase in density, not merely a layer of material on the surface. The team at the European Southern Observatory noted something else. When plotted against its pre-perihelion path, 3I Atlas appeared to have slowed slightly, as if its internal inertia had shifted. That minute deviation, though tiny on paper, means energy transfer and possibly mass gain. This isn't without precedent. In 2019, 2I/Borisov exhibited subtle brightening after perihelion, likely from internal ice exposure. But 3I Atlas doesn't behave like ice. It remained thermally stable under temperatures that should have vaporized volatiles long before it reached this point. Its composition, as far as spectra indicate, contains metallic traces rarely seen in typical comets: nickel, chromium, and possibly molybdenum. That combination resists thermal ablation, so when instruments recorded a momentary spike in coronal flux around the object, followed by silence, the idea of an absorption event became more than speculation. The term itself unsettled mission analysts. Absorption implies interaction, and interaction means exchange. During the perihelion window, solar wind pressure peaked at over 400 km per second, bathing 3I Atlas in a storm of charged particles. Any natural body would shed mass under that intensity. Yet somehow, this one held together, its magnetic environment briefly intensifying before collapsing again. The resulting halo, faint, asymmetric and short-lived, resembled what some researchers described as a temporary plasma envelope. One hypothesis suggests the object generated or induced a localized magnetic field, allowing it to capture and compress part of the surrounding plasma. If that happened, then what we witnessed wasn't erosion but ingestion. By early November, follow-up observations from infrared arrays in Chile and Spain indicated a persistent thermal anomaly trailing the object's outbound path. It wasn't a jet or debris field, it was heat, stored and radiating slowly, as though something beneath the surface was cooling from within. That pattern hints at internal absorption, where high-energy particles could have been trapped or redirected through a dense medium. In ordinary terms, it's as if the object swallowed a pulse of the sun's outer layer and kept it. The implications stretch beyond curiosity. A change in density without visible fragmentation challenges our understanding of interstellar remnants. If 3I Atlas truly gained mass, its structure must include voids capable of collapsing under pressure, sealing themselves in the process. That might explain why radar pings returned unusually flat echoes after perihelion. No resonance, no hollow reflections, just a uniform solid tone. Some researchers think this could mean internal melting or sintering, where metallic grains fuse under extreme heat, forming a compact shell. Others aren't so sure. They point to the coordinated drop in spin rate, noting that artificial object, probes or constructs, sometimes display similar dynamics after energy intake or system resets. The debate has fractured the small community tracking the object. The cautious group argues that 3I Atlas is still a natural fragment, perhaps from a planetesimal core ejected millions of years ago. The more speculative camp suggests we may be observing engineered behaviour, an adaptive mechanism designed to harvest energy or repair damage near a star. While the second view borders on science fiction, the data forcing the discussion is real. Every recorded metric, brightness decay, spin slowdown, heat retention, aligns with a process that doesn't dissipate energy but preserves it. As it moves outward again, past the line of solar interference, telescopes are slowly reacquiring the signal. Its new trajectory is slightly altered, its emissions quieter. There are no signs of disintegration, no expanding dust plume, only a faint thermal wake that refuses to cool. If the event truly was an absorption, it may have changed the object permanently, compressing it, shielding it, perhaps even reactivating something dormant within. As 3I Atlas reached its tightest orbital curve around the Sun, temperatures in its vicinity should have exceeded any limit known for stable matter. Calculations predicted that any remaining surface ice or volatile compounds would sublimate instantly, leaving behind a dim, inert rock. But the object defied that expectation in full. It endured. For nearly 20 hours, it remained within a region of solar radiation so intense that even hardened spacecraft shields would have failed. Instead of disintegrating, it showed a controlled thermal rise, measured, steady, and inexplicably delayed. Infrared readings collected from multiple instruments told a consistent story. The heat curve didn't spike all at once. It climbed in 3 distinct intervals, each one plateauing before rising again, as though the object was absorbing and redistributing energy in stages. This pattern mirrored how engineered systems handle overload, phase regulation, thermal dispersion, containment. Natural objects don't do that. They absorb until they fracture. But 3I Atlas managed its temperature with precision, as if guided by internal logic rather than chance. At the Max Planck Solar Observatory, a team monitoring the event described it as a thermal pacing mechanism. Their simulation showed that the heat retention was too localized to be random. The emission peaks aligned with small reflective shifts across the object's surface, forming geometric symmetry. The southern hemisphere of 3I Atlas, based on brightness differentials, appeared to expand slightly before contracting again. A pulse, almost biological in rhythm, but mechanical in structure. This expansion coincided with a measurable drop in infrared output, suggesting that the object was cooling itself by internal absorption. That discovery unsettled the analysts more than any previous anomaly. If 3I Atlas truly absorbed rather than emitted energy, its internal layers must be conductive, capable of trapping radiation and storing it. One researcher described it as a heat capacitor in motion. The energy didn't vanish, it moved inward, vanishing from the sensor's reach. When the object finally rotated to expose its opposite hemisphere, the spectrum shifted again, showing signs of new molecular bonds forming on its surface. The working hypothesis was that solar plasma had fused into the object's exterior layer, forming a composite crust. A process similar to sintering, where extreme heat compresses and welds particles together, might have taken place. Except this wasn't dust and rock compacting naturally. The resulting material displayed reflective properties consistent with alloy formation, particularly those rich in nickel and silicon. Those metals should have vaporized under that kind of radiation, yet somehow they stabilized. During a briefing at NASA's Goddard Center, analysts discussed whether this indicated self-healing. If the object possessed a shell capable of molecular reorganization, the so-called temperature spike might have been part of a repair phase. The heat, instead of destroying, triggered a response, one that strengthened it. This idea found partial support from the magnetic data. During the hottest point, the object's field briefly intensified, deflecting high-energy protons before collapsing again. That magnetic rise would have required coordination between internal layers, a system of dynamic currents rather than inert metal. Outside the technical community, the media narrative drifted toward speculation. Some headlines called it a solar-feeding event. Others drew comparisons to energy harvesting technology. Inside mission control, the mood was less sensational, but no less tense. Teams began double-checking the perihelion timing because the object's radiative output didn't match its expected position. It appeared to linger longer than orbital dynamics allowed. A delay of even a few seconds at that distance translates to a massive discrepancy in energy balance. Something had held it in position, or perhaps slowed it slightly. Meanwhile, data from the stereo probe captured something impossible to ignore: a faint arc of plasma looping from the sun's corona toward the path of 3I Atlas. It wasn't a flare, nor a random ejection. It was directional, a filament of charged matter that seemed drawn to the object like a magnetized tether. For nearly 6 minutes, the arc persisted, its luminosity fluctuating before fading into silence. That image, replayed in slow motion, became the most discussed frame of the entire event. If plasma transfer occurred, it might explain the subsequent mass anomaly detected later, an increase, not a decrease. Following the temperature peak, the object entered what scientists called its quiet phase. All readings flattened, no new emissions, no visible coma, nothing. But this silence was deceptive. When recalibrated instruments looked deeper into the infrared band, they found residual warmth where there should have been cooling. The object wasn't radiating heat away into space, it was keeping it. The gradient followed a smooth internal curve, as though the energy was circulating within. This behavior forced astrophysicists to confront an uncomfortable question. Could an interstellar object possess a structure capable of energy storage? If so, what mechanism would allow it to retain heat against the cold vacuum of space without radiating excess infrared? One theory proposed layered conductivity, alternating strata of conductive and insulative material forming a thermal trap. Another suggested that internal voids compressed during heating, creating pockets that confined plasma. Both explanations are speculative, but neither contradicts the data. When 3I Atlas finally began to exit the solar limb, something in its appearance had changed. The faint bluish hue observed for months before perihelion was gone, replaced by a dull metallic tone. It no longer shimmered. Its rotation slowed by nearly 9%, a subtle but measurable difference. These two changes combined to form a single conclusion across mission reports. Energy had been exchanged. To this day, analysts continue to debate whether that exchange was passive or deliberate, but the evidence remains clear. 3I Atlas entered the solar furnace, absorbed an amount of radiation that should have annihilated it, and emerged darker, heavier, and quieter, like something that had finished a task. When 3I Atlas reappeared from the far side of the sun, astronomers expected the standard recovery pattern, a gradual brightening as it reflected sunlight back toward Earth. Instead, the opposite occurred. Its luminosity collapsed. Within hours, the light curve, the graph of its reflected brightness, fell by nearly 60%. No comet or asteroid in recorded history had ever darkened that fast without physical disintegration. Yet radar echoes confirmed the object remained intact, its silhouette stable, its mass seemingly increased. Something about its surface had changed to absorb light, instead of reflecting it. At first, ground-based observatories assumed instrument interference. The sun's glare could easily distort readings, especially with the object still near conjunction. But as independent observatories across Chile, Spain, and Japan confirmed the same readings, the anomaly hardened into fact. 3I Atlas had become darker, denser, and strangely uniform. Spectrographic comparisons between pre- and post-perihelion phases revealed a flattening of spectral lines, the kind that occurs when reflective surfaces become coated with non-reflective material. This new layer didn't behave like dust or ice. It absorbed nearly all visible wavelengths while reflecting faintly in the infrared. The simplest explanation was chemical transformation. Extreme radiation can rearrange surface compounds, creating carbonized layers or metallic oxides. But there was a problem. 3I Atlas's previous composition showed no sign of carbon dominance. It wasn't a carbon-rich comet. It was metallic, possibly silicate with trace alloys. For such a structure to suddenly turn opaque across multiple bands, a massive infusion of charged plasma would be required, enough to fuse the outer layer into a metallic glass. That's precisely what the models began to suggest. NASA's solar dynamics team recreated the event using simulation software normally applied to spacecraft heat shielding. By inputting the solar flux intensity and trajectory data, the model predicted a rapid plasma exchange phase during perihelion. Instead of shedding material, the object's surface might have liquefied just long enough to trap coronal matter before solidifying again. The result would be a hardened, opaque crust capable of absorbing light far more efficiently than it reflected it. A process of self-sealing, or, as one researcher reluctantly put it, coating by capture. The moment this became clear, the next question surfaced. How could an interstellar rock manage controlled cooling without fragmenting? The answer came from the infrared tail. Data indicated that the object's heat emission dropped faster than expected, meaning it radiated less than its surface temperature predicted. That discrepancy implied that heat wasn't escaping from the surface evenly. Instead, it was being redirected inward or around, possibly through internal channels that distributed energy to prevent cracking. Again, this isn't behavior typical of natural debris. It's behavior consistent with systems that manage energy flow. As the light curve fell, telescopes in orbit began to lose visual lock. Optical tracking became nearly impossible. Radar and thermal imaging replaced it. The European Southern Observatory described the returning radar echoes as uncharacteristically flat. A clean, mirror-like return without scattering suggested the surface had smoothed dramatically. Irregular objects scatter radio waves chaotically. 3I Atlas no longer did. It reflected in unison, as though the entire body had become a single coherent shell. The change was so sudden that some astronomers questioned whether they were still tracking the same object. This event triggered what came to be known as the density paradox. Gravitational modelling from EA's Near-Earth Object Program showed that the object's trajectory had subtly shifted, not from external gravitational interactions, but from an internal adjustment in its mass distribution. That can only happen if density increases without volume expansion, which defies what we know about non-composite materials under solar heating. Simply put, 3I Atlas became heavier but didn't grow larger. In scientific terms, the phenomenon resembled absorption of particulate mass, as though the object had consumed fragments of solar plasma or micro debris while maintaining its structure. If correct, this means that at perihelion, matter from the solar corona fused into it, adding measurable density without producing ejecta. The absorption wasn't metaphorical, it was literal. The sun's outer layer, in microscopic fragments, became part of the object. At the Johns Hopkins Applied Physics Lab, data analysts cross-checked solar particle flux around the time of the event. They found a brief depletion in charged particles immediately downstream of the object's path, a localized vacuum effect. In that moment, solar density readings dipped below normal background levels, as if matter had been drawn inward rather than dispersed. For those few minutes, the sun lost a fraction of its own plasma to something passing through. When compared to the direction of solar wind flow, the anomaly lined up perfectly with the trajectory of 3I Atlas. The phenomenon left astronomers divided. The conservative explanation was that the object's composition caused it to polarize under extreme magnetism, briefly attracting ionized gas. The more controversial theory, the one circulating in closed scientific circles, proposed active absorption, a surface capable of pulling in charged material and binding it within molecular lattices, essentially energy harvesting at a cosmic scale. Regardless of interpretation, the result was undeniable. The object emerged from perihelion darker, denser, and radiating thermal energy, inconsistent with passive heating. It was no longer behaving like an inert mass of rock and metal. Something about it had changed permanently. The light curve drop marked more than a shift in brightness. It was the moment the scientific community realized 3I Atlas was rewriting the rules of interaction between interstellar matter and stellar environments. natural or not, it had demonstrated an ability to endure solar proximity by doing something counterintuitive. It didn't fight the radiation, it absorbed it. Right now, 3I Atlas is acting like nothing we've ever tracked near the Sun. Its radiation signature is flattening across the spectrum, as if it's no longer reflecting light but managing it. Instruments tuned to multiple bands are showing the same pattern, ultraviolet emissions dropping fast while infrared readings remain steady. Normally that means an object is cooling, but this one isn't. It's holding energy, keeping it contained, and releasing it in exact, even intervals. At the European Space Agency, scientists are watching the data feed live, and the graphs don't behave like a comet, asteroid, or even metallic debris. Instead of a chaotic energy profile, it's showing a smooth decline, as though it's deliberately regulating radiation. Some describe it as a controlled absorption field. Others refuse to call it that yet, because no natural object should be capable of such consistency. The Solar Orbiter and Parker probe are both detecting an odd calm in the plasma flow around it. Where turbulence should be violent, the readings are flat. It's as if the space around 3I Atlas is quiet, unnaturally so. A small region of silence is following it through the solar wind, dampening nearby charged particles. That effect shouldn't exist. Plasma doesn't calm itself around moving matter, it reacts violently. Yet here, the solar noise simply fades. Across multiple observatories, radar pings are coming back weaker than before. Signals sent toward the object are returning partially absorbed. This isn't distance interference. The energy is disappearing inside the object's envelope. Analysts are comparing it to an electromagnetic sink, a surface that consumes energy instead of bouncing it back. Each pass of data seems to confirm it. Every attempt to map its exact reflectivity fails because the return signal keeps dropping. The scientists on rotation tonight are starting to describe it in whispers, not because of fear, but because the data feels impossible. 3I Atlas isn't scattering radiation like dust or reflecting light like rock. It's pulling it inward, managing its temperature, and shaping its own emission curve. The math suggests that it's not emitting random heat. It's selective, letting only a narrow band escape, right where infrared telescopes can still trace it. The longer the object stays in this state, the stranger it gets. Even background noise around its position is dimming. Normally solar proximity would fill every sensor with static. Instead, the instruments are quiet. A subtle drop in broadband interference appears wherever the object moves, almost like it's suppressing the environment around it. That same suppression has now been confirmed by 3 independent data streams. It's also rotating slower. The shift is subtle but measurable, as if the object adjusted its spin intentionally. A slower rotation means longer solar exposure on each side, ideal for absorbing heat evenly. Whether that's coincidence or control is unclear, but the effect is precise enough to make scientists pause before they call it natural. The radiation signature, now stabilizing, suggests 3I Atlas may be storing energy within internal layers. If this continues, the stored energy could explain its unusual density readings and the faint afterglow detected trailing behind it. Observatories are reporting a weak, persistent infrared tail, not a dust plume, but a thermal echo, as though it's bleeding heat slowly from within. Right now, no one can say what mechanism is behind this. It could be a rare combination of metals reacting to solar plasma, forming a temporary conductive skin. Or it could be something more structured, a layered composition built to survive high radiation environments. Either way, 3I Atlas is no longer just reflecting the sun, it's interacting with it. And as the data keeps coming in, a faint distortion is beginning to appear around its outline. Something glowing, faint but symmetrical. Observers are calling it a plasma halo. No one knows yet if it's a byproduct of the heat, a reaction to the magnetic field, or something the object itself is generating. All they know for certain is that 3I Atlas isn't behaving like an object at all. It's behaving like a system. The first hints of the halo appear in raw imagery from the STEREO-A probe, faint but impossible to ignore. Around the dark body of 3I Atlas, a thin envelope of light begins to shimmer, a bluish haze wrapping its silhouette. At first, analysts assume it's a sensor artifact, the kind caused by cosmic rays striking the camera. But when multiple instruments across different wavelengths confirm it, the conclusion is unavoidable. Something is glowing around the object, and it's not reflected sunlight, it's plasma. The glow is structured. It maintains symmetry, forming a perfect elliptical shell that moves with the object instead of trailing it. Every second of data suggests it's magnetically bound, a cocoon of charged particles rotating in lockstep with 3I Atlas's slow spin. For the plasma to hold that shape, a magnetic field must be containing it. Yet magnetometers detect no strong external field. The only explanation is that the field is localized, perhaps emerging from inside the object itself. In real time, the glow is shifting colors. It pulses from white to deep violet, flickering in smooth transitions that follow the solar wind fluctuations. Instruments at the European Southern Observatory capture the same rhythm in polarization readings. It's almost synchronized. Not random flicker, but modulation. The plasma responds to the sun's output, adjusting in intensity as solar bursts come and go. It behaves as though 3I Atlas is absorbing those surges and balancing them through this halo, releasing excess charge in controlled waves. The Parker Solar Probe detects a small pocket of reduced plasma density trailing behind the object. That's a void, a wake where the usual charge particles thin out. To the team monitoring it, it looks like a pressure bubble, the kind you'd expect from a moving field displacing matter. But comets and asteroids don't create such perfect displacement patterns. The readings show consistency, as if 3I Atlas is gliding through plasma rather than colliding with it. A working hypothesis forms among the analysts. The halo could be a form of magnetic buffer. Instead of direct contact with the solar wind, the object may be surrounding itself with a thin shield of ionized particles, capturing plasma and spinning it around itself. This would explain how it survived perihelion without erosion. It didn't resist solar energy, it redirected it. As the object moves farther from the sun, the halo doesn't vanish. It changes. The intensity lowers, but the structure remains stable. That persistence is the part that alarms observers most. Normally, plasma discharges fade within minutes once they lose their energy source. Here, the glow lingers for hours, maintaining uniform shape even as radiation drops. That means the energy sustaining it isn't coming from the sun anymore. It's coming from within 3I Atlas. The color shift tells its own story. The spectrum peaks at specific wavelengths associated with excited hydrogen and oxygen ions. This could mean the object captured trace amounts of solar plasma and is now releasing them slowly, almost like fuel being burned off. If that's the case, then what we're seeing isn't just a residue of energy, it's a process still active right now. Several observatories begin experimenting with polarized filters to track fluctuations in the halo. What they find deepens the mystery. The field pulses in consistent intervals of exactly 3.9 minutes. Every cycle begins with a faint brightening on one side of the halo, followed by a dimming wave that travels around the circumference before resetting. It's too regular to be turbulence. One researcher at ESA's data center calls it heartbeat resonance. Right now, no natural explanation fits. The plasma density, timing, and longevity all suggest a coordinated mechanism. If the object is emitting magnetic pulses, they could be responsible for holding the plasma in place, preventing dispersion. The same pulses might be responsible for the slight deceleration in its trajectory, a byproduct of interaction between the field and solar radiation pressure. Whatever this halo is, it changes everything about how we interpret 3I Atlas. It's not just reflecting or absorbing energy anymore, it's manipulating it. A comet can't produce symmetrical ion structures like this. A rock can't regulate plasma waves with rhythmic precision. This behavior belongs to something either operating under physical principles we haven't yet observed, or something built to use those principles deliberately. As live feeds continue updating, the halo flickers again, brighter than before. The color deepens to a saturated electric blue, the same hue the object displayed months ago, before it even reached the sun. For researchers following the event in real time, that's the most unsettling detail yet. It means whatever process began before perihelion is still continuing stronger than ever. Spectral readings are now confirming what researchers have suspected for days. The surface of 3I Atlas no longer matches any known composition from its earlier phase. Before perihelion, its reflective spectrum indicated a mix of silicate dust, nickel, and magnesium, consistent with a dense metallic interstellar fragment. But right now, post-perihelion analysis is showing new chemical fingerprints. Traces of highly ionized iron and chromium have appeared in bands where there were none before. Even more confusing, the ratios between them are shifting slightly each hour, as though the material itself is still in flux. Laboratories running near real-time spectral modelling are struggling to make sense of it. To see metals reconfigure under solar radiation isn't impossible. Extreme heat can fuse elements into new molecular structures. But those reactions happen once, then stabilise. 3i Atlas seems to be continuing the process long after it should have cooled. Its surface is evolving under conditions that no longer exist. That means whatever transformation began near the Sun hasn't stopped. Infrared readings support this. The object's cooling rate remains unnaturally slow. A comet or asteroid should shed its absorbed heat in a matter of hours, yet 3i Atlas's temperature has plateaued, hovering at a stable level that suggests internal heat retention. Analysts suspect that the outer shell may have become partially molten or amorphous, a glass-metal hybrid layer capable of trapping heat below its surface. In simpler terms, the object's skin may have fused into a solid mirror, one that doesn't reflect but contains. At the European Southern Observatory, comparisons with known meteorite samples reveal another anomaly. The absorption lines of 3i Atlas correspond to materials that don't naturally coexist. Refractory metals combined with volatile compounds. One scientist describes it as a chemistry that shouldn't be possible without industrial conditions. The phrase catches on quietly within the internal reports, though no one dares say it publicly. For now, the working term remains unknown composite formation. Microwave spectrometry adds another layer to the puzzle. Some wavelengths are bouncing off the object with phase distortion, a clear sign of subsurface layering. That means 3i Atlas isn't homogeneous, it's stratified. Layers with different densities are stacked beneath the crust, each interacting with radiation differently. The data implies a design that regulates temperature and magnetic load, like a heat shield built in concentric shells. At the same time, magnetic sensors from the Parker Solar Probe detect faint, repeating fluctuations consistent with short bursts of alignment. Every few hours, the field around 3i Atlas adjusts slightly, as though internal components are orienting to solar magnetic lines. This could explain the oscillating readings in composition, each shift exposing a different surface mixture as the object rotates. The pattern is so regular, it almost resembles calibration. Ground observatories, tracking polarization, are noticing another detail. The light scattering off the object is now partially circularly polarized, meaning it's twisting in one direction as it reflects. This phenomenon rarely occurs in natural environments and usually requires specific surface structures, microscopic spirals or patterned metals. The implication is extraordinary. 3i Atlas's surface is not random. It's organized at a molecular level. Every data point strengthens the same conclusion. This object is no longer what entered the solar system months ago. The perihelion event didn't just alter its temperature or spin, it changed its material state. The once metallic grey reflection is now darker and more uniform, absorbing up to 95% of incoming light. The only remaining emissions are faint infrared glows escaping through microfractures. Researchers are beginning to debate whether this transformation could have been triggered intentionally. If the object was dormant, perhaps the solar encounter activated a reaction, one designed to stabilize it under extreme conditions. That theory remains speculative, but the timing fits perfectly. The moment it reached its closest approach, its structure changed in a way that ensured survival. Right now, telescopes are gathering deeper ultraviolet scans to probe the new layer. Early data hints at crystalline patterns, geometric lattices scattered across the surface. These are not cracks or fissures, but precise alignments of reflective points, forming hexagonal arrays. The structure repeats every few meters, far too regular to be a random outcome of heating. The shift in composition is no longer a theory, it's observable fact. 3i Atlas has turned into something different, denser, darker, and self-regulating. Whether this is a natural response to solar radiation or an engineered one remains unknown. But whatever process reshaped it has given it properties no asteroid or comet has ever displayed. Right now, magnetometers across 3 solar missions are detecting a phenomenon that shouldn't exist. A localized magnetic field surrounding 3i Atlas that fluctuates independently of the Sun's own magnetosphere. It appears and fades in intervals, pulsing every few minutes like a slow wave. Normally, an object that's small would have no capacity to generate a magnetic field of its own. It would simply drift, influenced by external forces, but this field is centered precisely around it, extending several thousand kilometers outward before collapsing back into silence. The Parker Solar Probe's readings are the clearest so far. As it crosses near the object's path, the instruments register a distortion in plasma density. Charged particles are deflecting smoothly around an invisible boundary, forming a perfect arc before resuming their normal flow. That behavior is identical to how magnetic shields work, the kind used to protect spacecraft from radiation. Yet there's no spacecraft here, no emission source, no mechanical structure to explain it. Only an interstellar object that seems to know how to bend the solar wind. At the same moment, data from the solar orbiter shows the same ripple effect in a different form. A faint oscillation in the magnetic field lines trailing the object. They aren't being dragged by gravity, they're being repelled. For a brief span of time, the surrounding space becomes magnetically quiet, stripped of the usual interference caused by high-energy particles. That silence can only mean one thing. 3I Atlas is generating or inducing a magnetic envelope strong enough to neutralize local turbulence. Back on Earth, analysts are debating two competing explanations. The first is purely physical, a reaction triggered by the object's new composition. If its outer shell became metallic glass, it might be conducting induced currents under solar exposure, momentarily producing magnetic loops. The second theory, more unsettling, is that the field is intentional, a byproduct of internal systems designed to control plasma interaction. Either way, the readings are consistent with magnetic behavior that adapts dynamically to its environment. When researchers map the changes frame by frame, a pattern begins to emerge. Each magnetic pulse coincides with minor fluctuations in the object's brightness. The relationship is too precise to be coincidence. When the field strengthens, reflected light drops. When it weakens, brightness rises slightly. It's as if the object is cycling between protective and absorptive modes, using magnetism to regulate energy intake. In simpler terms, it's breathing. At the European Space Operations Centre, the data team overlays the readings onto the object's trajectory. During moments of high solar activity, 3I Atlas's field expands. During calm solar wind, it contracts. This is the exact opposite of what should happen naturally. A passive body gets buffeted by plasma and overwhelmed. It doesn't anticipate the sun's mood. Yet 3I Atlas reacts before each burst reaches it, adjusting in perfect timing. That predictive response implies real-time adaptation, either from an unknown physical mechanism or from something designed to sense and respond. A small number of astrophysicists are beginning to whisper a comparison to controlled systems, magnetic confinement, similar to what fusion reactors attempt to achieve on Earth. Those devices use magnetic fields to contain plasma, keeping it stable within a precise boundary. 3. Atlas seems to be doing something similar, but on a natural, or perhaps engineered, cosmic scale. Its field forms a pocket of calm in an otherwise violent environment. Meanwhile, faint radio distortions are now being recorded each time the magnetic envelope activates. The signals aren't structured like communication, they're bursts of low-frequency resonance, the kind produced when charged particles spiral along magnetic lines. What's strange is their precision. They last for the same duration every time, as if the field is resetting itself on a fixed timer. It behaves less like chaos and more like calibration. Ground stations monitoring these events describe the surrounding region as electromagnetically dim. The normal solar hum, that background static that fills every channel near the sun, drops to nearly zero whenever the field peaks. Observers have started calling it the quiet zone. The name spreads quickly across mission reports. Each time the quiet zone appears, sensors across multiple spacecraft show identical flat lines. The object is absorbing the noise of space itself. Theories are diverging. Some physicists suggest the object's magnetic behavior could be a relic of its interstellar journey, perhaps remnants of an ancient magnetic core reactivated by the sun's heat. Others, less cautious, suggest the field is part of a self-maintaining mechanism, using stored solar energy to create temporary shields. That would explain the timing, the rhythm, and the energy stability seen in the last several hours. As of now, the envelope remains intermittent but stable, flaring up every few minutes like a pulse. The plasma halo around 3I Atlas glows brighter each time it activates, and when the glow fades, the object's infrared emission dips slightly, as if energy is being redistributed within. The link between heat and magnetism is undeniable. The turning point happens without warning. A sudden fluctuation in solar telemetry reveals that, for a span of 40 seconds, a measurable amount of plasma simply disappears from the region surrounding 3I Atlas. Instruments aboard the solar orbiter show a temporary drop in electron density, as though a portion of the solar wind has been drawn inward rather than scattered. No flare, no visible eruption, just absence. It's as if something in that zone swallowed a pulse of energy whole. Scientists on duty confirm the readings again and again, but the pattern holds. The depletion starts at the leading edge of 3I Atlas's magnetic envelope and moves inward in a wave. In the same instant, the plasma halo brightens sharply, turning from blue to an intense white flash before fading back to its original glow. Every major observatory watching the event captures it simultaneously. For a few heartbeats, the object absorbs part of the sun's output, not deflecting it, not reflecting it, but taking it in. The phenomenon is now being called an active absorption. It's not theoretical anymore. The instruments have seen it happen in real time. During the event, the local temperature in the surrounding plasma drops slightly, consistent with a sudden loss of kinetic energy. The object, on the other hand, shows a minor increase in thermal output, a sign that the missing energy went somewhere. The timing is exact, too perfect for coincidence. One side of the object glows briefly in infrared before returning to normal, as if an internal layer has taken the load and redistributed it evenly. For analysts following the data stream, the conclusion is hard to ignore. 3I Atlas isn't just enduring solar radiation, it's interacting with it directly. Theories start to converge on one idea: resonance capture. If the object's magnetic envelope vibrates at the same frequency as the solar plasma, it could, in principle, draw in charged particles and convert part of their motion into stored energy. That's a process not seen in any known natural body, but it's theoretically possible in engineered systems. At NASA's Goddard Data Center, the telemetry graphs are being replayed frame by frame. Each spike in magnetic field intensity corresponds perfectly with a dip in surrounding plasma density. The rhythm repeats at 20-minute intervals, like a breathing cycle. The pattern is consistent across 3 instruments, which means it isn't an artifact. The object appears to be feeding from solar plasma impulses, taking in energy, storing it, and stabilizing again. Observers comparing brightness maps notice another correlation: microflashes along the object's equator during the event. These flashes are so small they barely register visually, but they show up as temperature spikes on thermal sensors. The symmetry suggests an organized distribution system, not random eruption points. It's as if energy enters through one side of the object and exits through the other after processing. Ground-based magnetic readings detect subtle ripples spreading outward from the object after each absorption. These ripples move like shock waves, but in reverse. Instead of expanding outward from a blast, they contract toward the center. Each ripple ends with a faint distortion in the surrounding electromagnetic field, leaving behind a small bubble of quiet space. The field stabilizes seconds later, but the pattern is identical every time. Scientists are cautious in their wording, but behind closed doors, some have begun using a phrase that was once unthinkable: energy regulation. The evidence points toward a process that manages intake and output with precision. The timing, the uniformity, the repeatable intervals, none of it fits the chaos of a natural phenomenon. And as the solar orbiter's plasma detectors continue streaming data, the energy deficit around 3I Atlas grows measurable enough to alter the surrounding solar wind path slightly. The sun's own outflow bends around the object more than it should, as if space itself is reshaping to accommodate the event. ESA's deep space telemetry logs confirm that this isn't a one-time occurrence. 2 more pulses happen within the next hour, each weaker than the last but still distinct. Every time, the same pattern repeats: a plasma void, a thermal spike, a short-lived glow. Analysts can't yet determine whether the object is intentionally limiting these events, or if it's reaching saturation. Either way, 3I Atlas's behavior shows structure: cycles, reactions, and recovery phases. Right now, every major observatory is recalibrating instruments to monitor the intervals more closely. Scientists want to know whether the process is drawing power continuously or in discrete bursts. The fear isn't that it's dangerous, it's that it's deliberate. Objects don't regulate energy flow with this level of stability. Something is controlling what happens inside that magnetic shell. As the object continues its slow outward drift, new data begins showing faint gamma spikes that accompany each absorption pulse. They're small, harmless, but tightly timed. Gamma emissions mean high-energy transitions, rearrangements of atoms or particles at an energetic core. That could mean the plasma it's absorbing isn't just being stored, it's being used. The realization hits slowly but firmly across mission rooms worldwide. 3i Atlas is no longer a passive traveller through the solar system. It's an active participant in its environment, pulling in energy, releasing radiation, and maintaining stability through cycles that no random fragment could achieve. Each pulse suggests a purpose, a system designed for survival or adaptation. And right now, as the latest wave passes, instruments record a final flicker across all sensors, a narrow band signal at a frequency near 200 MHz, right at the threshold of radio detection. It's weak, irregular, and gone within seconds. But it's real. For the first time, 3i Atlas has emitted something measurable beyond reflected light. The aftermath of the absorption event leaves analysts more confused than ever. In theory, an object that endures that much solar radiation should lose mass through vaporization. But all new telemetry suggests the opposite. 3i Atlas is getting denser. Its orbital acceleration has shifted just enough to indicate a slight increase in gravitational influence, the kind caused by added mass. No debris trails behind it, no visible plume or fragmentation cloud can explain the change. Something inside that object has compacted or gained material. The European Space Agency confirms the anomaly with independent models. Using data from both the solar orbiter and ground-based radar arrays, analysts calculate that 3i Atlas's density has risen by roughly 8% compared to pre-perihelion estimates. That may sound small, but in astrophysical terms, it's enormous, the equivalent of billions of tons added or compressed into its structure. And yet, the volume hasn't changed. Its silhouette is identical, its dimensions unaltered. The term density paradox is starting to circulate in the internal communications. It describes what the models show but physics refuses to explain: mass without growth, compression without force. For natural bodies, this is impossible. When solar heat strikes a dense metallic surface, expansion is the only outcome. But 3i Atlas seems to be doing the opposite, stabilizing and thickening as though gravity within it is intensifying. At NASA's Jet Propulsion Laboratory, a specialized team begins reanalyzing radar reflectivity curves. They notice that return signals are slightly delayed compared to the pre-perihelion period, by microseconds too large to attribute to simple drift. The best fit for that delay is increased internal density. Radio waves are taking longer to bounce through the material. This implies that the object's internal structure has changed, becoming more compact and uniform. The heat signature provides more clues. Normally, an object that absorbs plasma should radiate excess energy for days. Instead, 3i Atlas cools quickly after each absorption pulse, almost too quickly. The surface temperature drops in a perfectly logarithmic curve, as if the heat is being drawn inward rather than escaping into space. That inward draw may be compressing the structure even further, energy converting into pressure, pressure turning into density. The physics of such conversion defies explanation under any known natural process. A few scientists are now proposing something that sounds more like engineering than geology. They suggest the interior might contain voids or microcavities that collapse under stress, sealing the object tighter each time it absorbs energy. Each collapse would increase overall density while maintaining external shape. In other words, the more energy it takes in, the stronger and heavier it becomes. That idea fits the readings perfectly, though it forces an uncomfortable question. What kind of structure could survive that kind of self-compression? The hypothesis that 3i Atlas is hollow in parts gains traction. If its interior once contained porous materials, maybe remnants of gas pockets or ancient ice, the intense solar heat could have vaporized those spaces, leaving behind fused metallic shells that close under pressure. That's a generous natural explanation, but it fails to account for the precision. The compression appears evenly distributed across its entire body, suggesting coordination, not random collapse. Meanwhile, new gravitational measurements from the Deep Space Network confirm a slight shift in trajectory, consistent with a heavier mass. The orbital deviation is small but measurable, forcing scientists to adjust their prediction models. Every recalculation puts the object on a slightly altered path, slower, more stable, as if it has anchored itself more tightly to the sun's gravity well. But despite the change in mass, it continues moving smoothly, without any tumbling or rotational chaos. That level of balance shouldn't be possible if the density change were uneven. Instruments in Chile and Spain now report that radar signals striking the object are returning with nearly uniform strength across its surface. There are no dead zones, no dips in reflectivity, which means its density distribution is perfectly symmetrical. In nature, no interstellar fragment ever achieves that kind of balance. Random formation leads to flaws and pockets of instability. Whatever 3I Atlas has become, it's stable down to a precision that rivals manufactured materials. For the first time, a quiet consensus starts forming among a handful of scientists. The object may not be inert. Its interaction with solar energy is systematic. Intake, compression, stabilization. Each cycle strengthens it. Each pulse leaves it more cohesive than before. The density paradox might not be a side effect at all. It might be the purpose. Infrared mapping adds one last piece of evidence. Tiny gradients across its surface indicate internal motion. Subtle heat differentials that move in synchronized waves from pole to pole. The motion resembles internal flow, as though the absorbed plasma is being channeled through hidden paths inside the object. That movement could explain both the uniform density and the magnetic oscillations recorded earlier. No one is ready to call it artificial, but the term self-regulating body appears for the first time in an ESA internal memo. It describes an object that maintains its own physical stability under changing conditions, not by chance, but by design. 3I Atlas may not just be enduring the sun, it could be using it, turning energy into structure, radiation into reinforcement. Right now, scientists are divided between awe and disbelief. Every new data set confirms that this object behaves more like a system than a rock. It absorbs, compresses, balances, and repeats, a cycle that mirrors life more than physics. The density paradox isn't a mystery to be solved anymore. It's a signature, the clearest sign yet that 3I Atlas is something fundamentally different from anything humanity has ever observed in the solar system. The deeper analysts look into the returning radar data, the stranger the silence becomes. When radar beams strike ordinary celestial objects, the signals echo back with slight irregularities, small fluctuations that reveal surface roughness, cavities or fractures beneath the crust. But every new pass over 3I Atlas returns something unprecedented: perfect uniformity. The echoes are flat, featureless, smooth to the point of artificial precision. It's as if the object's interior is absorbing sound the same way it absorbs radiation, swallowing every trace of energy that tries to penetrate it. The phenomenon first catches the attention of radar specialists at the Goldstone Deep Space Communications Complex. Their instruments register no internal reverberation at all. Instead of bouncing through layers of varying density, the radar wave simply dies, a clean cutoff with no aftersignal. That shouldn't be possible unless the material inside the object has zero discontinuities. Even solid iron asteroids scatter radar energy. 3I Atlas somehow does not. The object behaves like a single, cohesive block, or like something deliberately built to dampen incoming waves. At the European Southern Observatory, analysts call the effect structural silence. The term spreads through the scientific community almost instantly. It means that every signal sent toward the object vanishes within it, with no resonance, no delay, no reflection from internal fractures. The only return comes from the outer boundary, a thin, uniform shell that defines the object's shape and nothing else. The interior remains completely opaque to every form of probing radiation. Infrared spectrometry confirms the same story. The surface still radiates residual heat, but the temperature remains uniform across every measurable point. Normally, even a small variation in texture or composition would create hot and cool patches, but 3I Atlas glows with eerie consistency. That suggests internal conduction, energy moving freely through its body without resistance. It behaves like a perfect thermal medium, something engineered to balance temperature instantly across its surface. When scientists attempt low-frequency scans, the outcome is even more unsettling. The waves don't echo, they vanish. That means the interior either absorbs vibrations entirely or is hollowed in a way that traps them indefinitely. but the object shows no signs of hollowness in its gravitational profile. Every test points to the same impossible conclusion. It's solid, but acoustically dead. The NASA radar team begins comparing the readings to engineered materials known for energy absorption. Foams, metamaterials, experimental alloys, none match. The closest analogue is the behaviour of stealth coatings used on spacecraft and aircraft, designed to scatter radar and prevent detection. But 3i Atlas does more than scatter. It cancels. The energy entering it seems to neutralise itself, leaving nothing to return. One working hypothesis suggests that the internal structure might be organised at the molecular level to produce phase cancellation. Every wave that enters meets its mirror opposite, erasing both. If that's true, then 3i Atlas isn't just a dense object, it's a near-perfect absorber, a machine made to remain invisible, even to instruments designed to find the faintest reflections in deep space. But silence has its own signature. As the object drifts farther from the Sun, its uniformity begins to look less like nature and more like design. Observers note that even after the most intense solar exposure in recorded history for a small body, 3i Atlas still shows no visible cracks, no irregularities, no dust plume. The surface remains immaculate, untouched by the chaos of its environment. That level of perfection cannot last without maintenance, yet the object appears to maintain itself. Researchers studying the radar suppression pattern make another discovery. The depth of the silence, the range within which waves vanish, is not constant. It oscillates slightly, expanding and contracting every few minutes in sync with the faint magnetic pulses detected earlier. This correlation suggests that the internal structure may be shifting or resonating in tandem with the magnetic envelope. When the field strengthens, the silence deepens. When it weakens, faint noise returns. It's as if the object can tune its own transparency at will. In response, several observatories begin coordinated efforts to monitor those cycles. The pattern repeats with perfect timing, confirming that this isn't a random effect. 3i Atlas seems to be managing its visibility the same way it manages its radiation, through deliberate rhythm. The idea is staggering. An interstellar object capable of choosing when to be seen. The most advanced modelling available can't simulate such behaviour. Even if the object were made of perfectly conducting metal, radar energy should bounce back at least partially. But 3i Atlas absorbs it completely. It's as though its very geometry nullifies incoming waves, reshaping them internally and releasing nothing. The silence is too complete, too exact to ignore. At NASA's Planetary Defense Coordination Office, one analyst quietly writes in a memo that the object's profile resembles a stealth configuration adapted for plasma environments. The line is removed before publication, but copies circulate through encrypted channels among researchers. For the first time, official language begins to acknowledge what many have already realised, that the object's behaviour aligns more with controlled technology than with geology. Right now, as the LOIF feed updates, radar operators confirm yet another silence phase. Every transmission sent toward the object vanishes. The instruments themselves record the absence. An empty return so absolute it feels physical. Even light seems to bend differently near it, scattering slightly less than the surrounding stars. Whatever 3i Atlas has become, it's no longer just dense. It's invisible by choice. As the glow around 3i Atlas fades into the cold dark of interplanetary space, a new pattern begins to emerge. One that is more subtle, but perhaps even more telling. Every instrument sensitive to heat, from infrared telescopes in Chile to the Parker Solar Probe's onboard sensors, is recording the same anomaly. The object refuses to cool. Weeks have passed since perihelion, and by all known physics, its surface temperature should have dropped near freezing. Instead, it remains warm, steady, consistent, as if the heat absorbed near the Sun is still trapped deep within. The readings aren't static. They fluctuate slightly, rising and falling in a predictable rhythm, like the respiration of a living system. Each pulse corresponds with a faint dip in surrounding infrared background, meaning 3i Atlas isn't just radiating energy, it's cycling it. For every wave it emits, it seems to draw in a fraction of that energy again, like a feedback loop. Natural bodies don't behave this way. When they radiate heat, it escapes irreversibly. But 3i Atlas appears to be keeping a fraction of everything it releases, recycling warmth like a machine designed to conserve power. The European Space Agency's Infrared Coordination Group publishes an internal notice tonight describing the phenomenon as thermal persistence. It's the first time this term has been used to describe an interstellar object. The report outlines how 3I Atlas's infrared curve has flattened into a repeating sine wave. Not random decay, but stable oscillation. Something is actively regulating the object's internal temperature. Either heat is being redistributed through an internal lattice, or the object has found a way to store radiant energy without releasing it all at once. Infrared imaging also reveals faint hotspots migrating across its surface. They don't follow the path of solar illumination. They move independently, drifting from one hemisphere to the other with precise timing. The pattern repeats every 90 minutes. That could mean internal convection, energy travelling through a structured medium. But the symmetry makes it look too controlled, too deliberate. The hotspots don't spread like thermal diffusion. They trace exact paths, as if following invisible conduits beneath the crust. At NASA's Jet Propulsion Laboratory, thermal engineers run simulations to test one extraordinary possibility: that 3I Atlas's structure allows energy to flow freely within without escaping. The model uses conductive filaments, metallic veins connecting multiple layers, channeling heat from the surface to the core and back again. The result matches the data perfectly. It predicts the same oscillating infrared pulse being seen in real time. If the model is accurate, the object functions as a closed-loop energy system, absorbing radiation, storing it, and releasing it gradually to maintain equilibrium. This theory gains strength when the Parker Solar Probe picks up low-frequency electromagnetic emissions synchronized with those same temperature shifts. The correlation is exact. Every time the object warms slightly, a magnetic pulse follows. Every time it cools, the field collapses. That means the heat is powering something. The magnetism isn't a byproduct, it's a product. Energy retention inside 3I Atlas isn't passive storage, it's conversion. Researchers are beginning to refer to the phenomenon as an energy circuit. If true, 3I Atlas may have mechanisms, or natural processes behaving like mechanisms, that manage thermal flow with precision unknown in astrophysics. One scientist privately calls it stellar metabolism. The phrase catches on, it fits too well. The object takes in energy, processes it, and emits controlled byproducts in the form of magnetic and infrared waves. It's behaving like a closed, self-sustaining system, not a rock, but a reactor. To test this, instruments at the Very Large Telescope in Chile are now measuring photon delay during infrared emissions. Light from 3I Atlas is arriving fractionally slower than from background sources in the same field. The difference is microscopic but measurable, consistent with photons scattering through a plasma sheath before release. That could mean the energy is being stored just beneath the surface, a layer acting as a containment field, re-emitting energy gradually rather than instantly. Even more unsettling is the timing. The oscillation period of the thermal wave has shortened slightly over the past 48 hours. It's becoming faster, more efficient. The object's temperature range is narrowing toward a perfect equilibrium, neither heating nor cooling too far in either direction. It's adapting, refining its balance, as if learning from its own feedback. The energy retention is so stable now that analysts can predict the next thermal surge to within seconds. That level of predictability defies randomness. It implies a controlled system with measurable response times. In a closed meeting between ESA, NASA and JAXA, officials discuss whether 3I Atlas could represent a self-regulating reactor, one capable of maintaining power far beyond the limits of any human technology. The conclusion is cautious, but unanimous. The possibility can't be dismissed. At the same time, the faint radio pulse first detected during the absorption event has returned. It now occurs at the peak of every thermal cycle, lasting less than 2 seconds. The frequency is identical each time. Analysts aren't calling it a transmission, but they can't explain it either. It behaves like a synchronization beacon, a marker that announces the completion of each energy cycle. The realization spreading across research centers tonight is both thrilling and terrifying. 3I Atlas is no longer just an interstellar traveler reacting to sunlight. It's maintaining a stable energy state long after exposure. It's regulating itself, cycling heat, and generating power from within. The scientific community is dividing into 2 clear camps tonight, and the tension between them is palpable. One side, The conservative majority insist that 3I Atlas is still a natural object, a rare but explainable product of interstellar chemistry and solar interaction. The other, quieter but growing camp believes something else entirely. They argue that what we're seeing now, structured magnetism, energy retention, compositional evolution, cannot happen by chance. It's not responding like a comet or a metallic fragment. It's behaving like something with intention, or at least with function. The naturalist argument is cautious but thorough. They point out that 3I Atlas may have formed in an environment radically different from our solar system, a region rich in heavy elements and plasma interactions that could create exotic compounds unknown on Earth. Under such conditions, they say, materials might exist that self-regulate temperature, or even generate magnetic fields under radiation stress. They compare it to piezoelectric crystals, which can produce electric currents when compressed, or to rare earth metals that shift atomic alignment under magnetic influence. Perhaps 3I Atlas is a cosmic-scale version of such phenomena, a natural machine without needing design. But the opposing view is harder to dismiss with each passing hour. The skeptics of the natural model point to the precision. Nature doesn't make perfectly symmetrical energy cycles or repeatable emission patterns. It doesn't turn solar plasma into uniform density increases or radiate in mathematically stable intervals. It certainly doesn't pulse radio frequencies at the exact midpoint of thermal oscillation. Every new observation seems to push 3I Atlas closer to the realm of engineered systems, a structure built to survive, harvest, or study energy from stars. ESA's latest summary lists 10 confirmed anomalies: absorption without outgassing, magnetic confinement, plasma halo persistence, synchronized thermal cycling, density increase without volume change, acoustic suppression, selective emissivity, and consistent radio pulses. Each one is extraordinary on its own. Together they make coincidence nearly impossible. The pattern feels deliberate. Something is maintaining this balance. At the Harvard-Smithsonian Center for Astrophysics, one theoretical physicist describes the situation in stark terms. If this is natural, it's rewriting physics. If it isn't, it's rewriting history. That line echoes through newsrooms and internal channels alike, though officially no one dares to frame it as evidence of technology. The word artificial remains banned from all formal communications, but off the record, scientists are using it freely. NASA analysts quietly model an alternative scenario, that 3I Atlas is not a solid object at all, but a containment shell. In this model, the visible structure is a housing around something else, perhaps a magnetic core or a field engine designed to capture stellar energy. The halo, the silence, the cycling heat, all could be byproducts of a system regulating internal stability. The simulations fit almost perfectly. A hollow sphere with a dynamic magnetic layer could replicate every signature observed so far. Meanwhile, SETI, long silent on the topic, has begun scanning the region again, this time for modulated frequencies within the weak radio band. Nothing structured appears yet, but their instruments detect something even stranger. Periodic narrowband noise aligning precisely with 3I Atlas's position. It isn't communication, but it's not random either. The signal follows the object, fading and returning with each energy pulse. It's faint, rhythmic, and mechanical. The growing sense among observers is not fear but unease, the feeling that we're witnessing something that isn't meant to be hidden or seen but merely functioning. The object doesn't react to observation. It doesn't respond to radar or light. It just continues its cycles, indifferent to the attention it's drawing. That indifference feels almost eerie, like watching a colossal machine running on ancient programming that no longer recognizes its surroundings. The natural model is still the official one. Public statements describe 3I Atlas as an exotic but natural interstellar body. But inside the data rooms, conversations are shifting. Too many coincidences, too much precision. The temperature modulation resembles power regulation. The magnetic oscillations match engineering efficiency curves. Even the plasma halo pulses follow harmonic ratios that look deliberate. A small group of researchers within NASA has begun cross-referencing the data with historical anomalies, signals and readings from previous interstellar visitors like Oumuamua. Some patterns match faintly: unusual acceleration without visible propulsion, stable spin, low reflectivity. But 3I Atlas amplifies all of these by orders of magnitude. Where Oumuamua whispered, 3I Atlas roars. quietly but unmistakably. Tonight, a private briefing between ESA and NASA officials reportedly ends with a single conclusion written in cautious language. If artificial, it is not signalling, it is maintaining. The sentence is left unexplained, but its meaning is clear. Whatever 3i Atlas is doing, it's not trying to communicate. It's surviving, adapting, or completing a process that began before humanity ever saw it. Outside the agencies, debate spills into the public. Amateur astronomers are uploading infrared frames showing faint oscillations around the object. Forums light up with speculation about alien craft, autonomous probes, or stellar reactors. Scientists continue to deny such claims, but privately many are no longer certain what denial even means. Right now, 3i Atlas remains stable. Its glow persists, its temperature steady, its radio pulses rhythmic. The arguments about its nature will continue, but one fact has already reshaped how we think about interstellar visitors. This object is not simply passing through. It's interacting, adapting, and enduring, with precision no natural law can fully explain. The world's observatories are in a state of quiet frenzy. Every major facility, from Hawaii to the Atacama Desert to the Canary Islands, has turned its instruments toward 3i Atlas. The tone among scientists is no longer detached curiosity, it's disbelief laced with awe. For the first time in modern astronomy, an interstellar object is not fading from study, but deepening in mystery with every new frame. Its energy cycles, its thermal rhythm, and its perfect silence are now the most discussed phenomena on Earth. At the European Southern Observatory, the director convenes a late-night briefing that quickly spreads across agencies. The central question is no longer what is 3i Atlas made of, but what is it doing? The infrared data shows the same repeating pulse pattern confirmed by NASA and JAXA, and those pulses are starting to show subtle variation, micro-delays that seem to correspond to solar activity. Each time the sun releases a flare, the object's rhythm shifts slightly, as if it's adjusting to the new electromagnetic conditions. The timing is exact down to the second. ESA's magnetodynamics team issues a confidential report tonight describing what they call synchronous field adaptation. The report's language is clinical, but the implications are extraordinary. 3i Atlas appears to anticipate solar fluctuations before they reach it. Either its magnetic field reacts faster than radiation can travel, which is physically impossible, or it's predicting them based on cues our instruments can't yet detect. A natural body cannot predict anything. At NASA's Jet Propulsion Laboratory, engineers who normally deal with spacecraft telemetry are now poring over astrophysical data. They've been asked to treat 3i Atlas not as a comet, but as a system. The approach changes everything. Once modelled as an active, self-regulating object rather than a passive one, the data suddenly makes sense. The heat retention, the plasma halo, the density fluctuations all fit into a single framework, an energy management cycle. To the team, it looks less like geology and more like engineering. Behind closed doors, several observatories are coordinating real-time observations to test the response theory. They send low-power radar pulses toward 3i Atlas at timed intervals to see whether its next energy cycle changes in any measurable way. The result is subtle but undeniable. After each directed pulse, the object's infrared output shifts slightly, as if it registers the incoming energy and compensates for it. It doesn't react violently or erratically. It adjusts calmly, like a stabilizer resetting after a nudge. The discovery sends shockwaves through the international network of scientists watching the event unfold. Meanwhile, the James Webb Space Telescope has begun its own long-range observations using near-infrared spectrometry. Preliminary readings are showing faint emission lines that suggest internal excitation, specific wavelengths of light that can only occur if atoms are being agitated in an organised repeating process. That's a signature of machinery, not mineralogy. Still, the Webb team remains cautious, refusing to draw conclusions until more data arrives. But privately, several astronomers admit that they have never seen a natural emission spectrum with such regular spacing between peaks. At the Keck Observatory in Hawaii, astronomers detect an even more surprising detail. The polarization of light from 3i Atlas is shifting over time. Polarization is normally fixed for reflective bodies, determined by the angle of light hitting their surface, but in this case it's rotating slowly, almost like a coded sequence. The rate of rotation matches the thermal cycle. one full rotation every 90 minutes. That connection means the light isn't random, it's being modulated by the same process controlling the object's heat. Inside the control rooms, the atmosphere feels more like a mission briefing than an observation. Scientists speak in short, tense sentences. Every time a data feed updates, someone cross-checks it with 3 others. The pattern holds, the object's magnetic and thermal cycles remain synchronized, its density steady, its reflectivity almost zero. The silence that once confused radar operators now seems purposeful, part of the same network of effects. It's absorbing, balancing, adjusting, not reacting chaotically, but with control. The public, meanwhile, is beginning to sense that something is happening. Although agencies continue to release only filtered updates, information is leaking through independent networks. Amateur astronomers are sharing infrared captures showing the rhythmic flicker, claiming to see heartbeat pulses in the object's light curve. News outlets are cautious, avoiding sensational claims, but speculation is spreading fast. The phrase, "the living object," trends worldwide. In an emergency meeting held between representatives of NASA, ESA and Japan's Space Agency, the directors agree on one principle: transparency could cause panic. The object's behavior must be described in strictly scientific terms: thermal oscillations, magnetic stabilization, surface reconfiguration. Words like engineered or technological are forbidden. Yet, within those same meetings, the tone has shifted. No one openly says it, but no one argues against it either. The possibility of artificiality is now quietly accepted as one working hypothesis among several. At midnight GMT, a joint statement drafts internally but is not released. The object designated 3I Atlas continues to demonstrate stable energy, retention, and magnetic field modulation inconsistent with standard physical models. Further observation is required. The release never goes public. Instead, the agencies decide to keep the phenomenon under continuous watch until the next solar event. For now, every observatory remains focused on a single question: what happens when 3I Atlas faces another surge from the Sun? Will it feed again, pulse again, or reveal something new? The data feeds remain steady, the glow constant, the rhythm undisturbed. The scientists are waiting, instruments locked, watching for any flicker that breaks the pattern. Because if it reacts again, if it repeats the absorption, it will confirm beyond any doubt that this object isn't just adapting to its environment, it's interacting with it. And that realization, quietly circulating among those who know what they're seeing, is already changing how humanity understands what might be moving between the stars. As 3I Atlas moves farther from the Sun, its path is becoming clear enough for telescopes to study every nuance of its motion. What should be a simple outbound trajectory now reads like the after-signature of a system adjusting itself after intense stress. Its spin has slowed slightly, stabilizing into a constant rotation that feels intentional, steady, efficient, and mathematically perfect. There are no signs of tumbling, no flickers of instability. It's travelling in silence, but its silence carries pattern. Every hour brings in data that deepens the paradox. The object is losing brightness, yet not in a way that corresponds to distance. The decay is linear, a controlled dimming. Spectrographs show that the infrared pulses are still there, weaker now, but precisely spaced. It's as if the system is winding down from high output to low power, conserving what it absorbed near perihelion. At the same time, the plasma halo hasn't vanished. It lingers as a faint electromagnetic shell, rotating in sync with the object's slow spin. Scientists at the European Space Agency call this phase thermal retirement, the period where a heated body should release its remaining energy into space. But 3I Atlas is doing the opposite. Its temperature remains steady, the same narrow band it held near the Sun. That means it's not cooling naturally. Something inside is managing equilibrium, perhaps drawing minimal power to keep internal systems active. The phrase "standby mode" has appeared in 2 private memos, written cautiously, then deleted from official logs. The orbital models show another anomaly. Instead of drifting outward along the projected hyperbolic path, 3I Atlas has shifted slightly, just enough to hint that it's steering. The deviation is minuscule, no more than a few hundred meters per second in delta velocity, but it's consistent over multiple readings. It's not gravity, not drag, and not solar radiation pressure. The simplest explanation is internal force, a change in mass distribution, or a release of energy from within. For a natural body, that would mean jets or outgassing, but no such plume exists. For a constructed system, it would mean propulsion. NASA's Deep Space Network records another pattern, a faint electromagnetic oscillation that trails the object like a heartbeat echo. The rhythm matches the earlier magnetic pulses detected near perihelion, but now it's slower, a long drawn-out breath every few minutes. The waveform is stable and clean, identical across sensors thousands of kilometers apart. Whatever it's doing, it's deliberate enough to synchronize with itself across every measurable frequency. At the Atacama Large Millimeter Array, researchers detect a new signature. The object emits a thin band of microwave energy that fluctuates in intensity with each thermal pulse. It's not communication, but it's not random either. The wavelength corresponds to hydrogen spin transitions, a frequency commonly used in theoretical propulsion concepts involving plasma confinement. Some speculate quietly that 3I Atlas might be using residual solar plasma as fuel, expelling it in microscopic amounts to correct its trajectory. If true, it's functioning as a self-sustaining engine, powered by what it absorbed from the sun. As it glides farther from the inner solar system, the void it leaves behind tells its own story. Instruments that once struggled with interference now report pristine signals. The electromagnetic turbulence that surrounded 3I Atlas during its solar encounter has vanished completely, leaving behind only a faint magnetic trail that dissipates with distance. Yet even now, the object maintains perfect coherence. Its field doesn't decay the way a magnetized asteroid's would. It persists, like an operating system that refuses to shut down. Teams comparing optical frames from before and after perihelion notice a subtle change in shape. The object's silhouette looks slightly more compact, its profile smoother, almost aerodynamic. That may be illusion, a trick of brightness and shadow, but if real, it would mean the structure physically altered itself after the solar encounter, sealing or contracting to a more stable form. Some researchers propose that the intense heat could have triggered a phase change in the material, turning the outer layer into a metallic shell. Others think it adjusted mechanically, like plates closing over an internal mechanism. At ESA's command center, the latest gravity models are starting to treat 3I Atlas as a single, rigid mass rather than a composite. It behaves less like a body of rock and more like an integrated object, a single component moving through vacuum with efficiency no fragment could match. The new estimates suggest that it will remain stable for decades, perhaps centuries, before radiation or collisions disrupt its equilibrium. The magnetic envelope, now weaker but still present, interacts faintly with the solar wind even at this distance. Occasionally a small ripple of light flashes across the halo, too faint for the naked eye, but visible in time-lapse composites. Each flash coincides with minor surges in solar activity, as though 3I Atlas continues to sense the sun from afar. It's not feeding anymore, but it's still listening. There's also a new development that few outside the inner teams know about. Deep space antennas in Australia and California have both detected recurring blips at the same frequency as the object's magnetic cycle. The signals are faint, almost lost in background noise, but they align perfectly with the rotation period of 3I Atlas. It's impossible to determine whether they're deliberate emissions or simple radiation leaks from residual plasma. Still, the timing is too perfect to ignore. For now, scientists describe this as residual electromagnetic coupling. In less cautious terms, the object may still be active. It's not decaying or drifting into silence. It's stable, alert, and holding its position like a probe waiting for instruction. The question everyone is quietly asking, though no one says aloud, is what happens next. Will 3I Atlas continue outward forever, dimming into interstellar space? Or will it react again when the next solar cycle peaks and the sun's magnetic field reverses? For now, it remains suspended between possibilities, not gone, not inert, and not fully understood. Its glow is faint but steady. The instruments still track its pulse, and though the headlines have faded, every major observatory on Earth is still listening for the moment the silence breaks again. The world's focus has quietly narrowed to a single question. What does 3I Atlas mean for us? Its behaviour no longer fits into the categories that science relies on. Not comet, not asteroid, not debris. It's become something else entirely. A system that absorbs, adapts, and stabilises with intention written into every cycle. The data is clear, the debate is not. In meeting rooms from Pasadena to Darmstadt, scientists are trying to agree on what they've actually witnessed. The official line remains cautious. Agencies describe the object as an energetically anomalous interstellar body. But off-record conversations tell a different story. Several leading researchers privately admit that this event feels less like a discovery and more like a realization, as though something long suspected has finally shown itself. The idea that intelligence in the universe may manifest through technology rather than biology is no longer theoretical. 3I Atlas has made it tangible. Every phenomenon observed so far, from the magnetic envelope to the perfect thermal rhythm, suggests not randomness but optimization, and optimization implies purpose. Whether that purpose is survival, observation, or energy collection remains unknown. But one fact is becoming hard to dismiss. The object interacted with the Sun and left more stable than it arrived. It used chaos to create order. NASA's energy modelling team now believes that the process observed near perihelion represents an advanced form of stellar energy extraction, a way to capture plasma and store it as usable power. If true, this could redefine how civilizations across the universe sustain themselves, not through planets or atmospheres, but through direct interaction with stars. The Sun may not have simply burned across 3I Atlas, it may have charged it. Philosophers and scientists alike are beginning to debate what it means for humanity to witness a system that behaves with such precision. If it is natural, it reveals that the laws of the cosmos are capable of producing structures indistinguishable from design. If it is artificial, it means that something, or someone, built a machine to operate across millennia, crossing from one star to another, feeding on light and plasma along the way. In either case, it changes everything we thought we knew about cosmic isolation. At ESA headquarters, one physicist described it quietly in an internal memo. 3I Atlas is the first time we've seen a body act with logic, but without communication. The phrase resonates across agencies. It captures the paradox perfectly. Something functioning but not interacting, stable but not inert. It doesn't signal or defend itself, it simply continues. Outside of the science, governments are reacting differently. Intelligence agencies are quietly requesting priority observation time on major telescopes, citing planetary defense coordination. But most scientists know that the object poses no threat. It's leaving, not approaching. Its behavior isn't aggressive, it's indifferent. Still, the mere idea that something out there can manipulate stellar energy is enough to unsettle those whose job it is to imagine worst-case scenarios. For now, the data flow continues. 3I Atlas is moving beyond Mars's orbit, faint but still trackable. Its brightness is nearly gone in visible light, but its infrared pulse persists, perfectly rhythmic. The energy within it has not decayed. It's conserving, as if preparing for another long silence between the stars. Every hour, somewhere on Earth, a scientist stares at the new data and feels the same realization forming. We may not be observing an object at all, but a behavior. The precision, the cycles, the harmony with stellar fields. They describe not a structure, but a pattern of control, a kind of quiet persistence that doesn't need to reveal intent to express purpose. Whether 3I Atlas is a remnant of something ancient or a probe still fulfilling a function, humanity has already crossed a threshold. The observation alone proves that the universe holds mechanisms we are only beginning to understand. Systems that act with the logic of life without any sign of it. Right now, 3I Atlas is drifting outward through the cold, carrying its hidden charge, its silent glow, and the unanswered questions of every person who's watched it. No transmission follows it. No flare marks its path. Just the faint rhythmic pulse of a system still awake after surviving the sun. And somewhere, in the space between stars, that pulse continues, steady, deliberate and endless. A reminder that in the quiet of the cosmos, not everything that endures needs to speak to be alive. The data feeds are quieter now. The instruments still watch, but the urgency that filled every control room has faded into something deeper, reflection. 3I Atlas is no longer a point of light in the solar system. It's a question written into space itself. The sun has released it. The solar wind carries it outward, and yet the memory of what it did lingers. A silence that hums with purpose. No signal has followed. No deviation has pulled it back. It simply drifts, pulse steady, field stable, energy balanced. every reading points to the same quiet truth. Whatever this object is, it knows how to exist in equilibrium with the universe, to endure the sun's fury, to emerge stronger, and to leave without trace. That is not survival by accident. It's survival by design. At observatories around the world, screens display the same diminishing trace, a faint heartbeat of heat moving through darkness. Scientists study the rhythm, still unsure whether they are witnessing physics or intelligence. But maybe those two things were never separate. Maybe what we call intelligence is simply matter arranged in a way that understands the rules of energy better than we do. The story of 3i Atlas isn't finished. It's just too far for our instruments to follow. Somewhere beyond the orbits of the planets, the object continues its course, carrying within it the heat of a star and the silence of a secret not meant to be broken. Its energy is constant, its signal faint but alive, a quiet reminder that not everything luminous seeks to be seen. For now, the sun grows smaller in its wake. The plasma that once fed it fades into ordinary starlight. Earth turns, the telescopes recalibrate, and humanity is left with the realization that we might not be alone in intelligence, only in awareness. And as 3i Atlas drifts into the dark between stars, colder, quieter, but still pulsing, one thought remains impossible to escape. The universe may not just contain life, it may remember it.